Hey there, welcome back. This is section 1.4. We're going to learn about the distributive property, a very, very important property. So, when we are doing order of operations to simplify an expression, we are only able to simplify it into like terms, right? So, I could end up with something like x plus 4, and there is nowhere I can go from that unless I know what x is. I cannot simplify further, so I'm going to say completely simplified. Completely simplified right there. So, the distributive property comes in when we say, all right, let's say we get down to x plus 4, but here's the catch. It's inside of parentheses, and we have to multiply it by 2. Because I need to do the parentheses, the p first, I need to make sure that that's done, right? It's completely simplified as much as I can. But I can't make it any smaller than that. So I have to figure out how I'm going to do 2 times x plus 4. The answer is we are going to use the distributive property. So the distributive property is where you take the 2 and you multiply it by the x, and then you take the 2 and you multiply it by the 4 as well. And that's going to give me 2x, 2 times x, plus 2 times 4. So I get that equal to 2x plus 4. Okay? Now, seems weird, right? Let's do it with something that's all numbers to show that it really works. So I'll say 5 times 3 plus 4. So when I'm doing order of operations, I could say, all right, I am going to have 5 times 3 plus 4, I turn into a 7. Now I do 5 times 7, which gives me 35. I can use the distributive property for this as well. And I could say, okay, well, let's try solving it with that. I'm going to do 5 times the 3, and then 5 times the 4. So 5 times 3 plus 5 times 4. And I get 5 times 3 is 15, plus 5 times 4, which is 20. And then 15 plus 20 is going to give me 35, which is exactly what I got over there. So that is proof that this works. And you might be thinking, well, why would I do all of these steps when I could just do it like this? And you're absolutely right. When you just have numbers, it's not very logical to do the distributive property to evaluate. But when you have something that has a variable in it that you cannot make any smaller, you cannot simplify out that operation, that addition sign, then you are forced to use the distributive property to move on to the next step of simplifying. All right, so let's look at a couple more. How about we do 2 times x plus y. 1, 2. So I'm going to be doing that equals 2 times x plus 2 times y. And that one actually is already simplified. We're all good like that. let's pause our examples and write down an official definition for the distributive property. So we are going to say for any numbers A, B, and C. So remember we did that in the last section with our properties as well, because this is another property. We say that A times B plus C must be equal to A times B plus A times C. And we say that B plus C times A, just switched around, is going to be equal to B times A plus C times A. And A times B minus C equals A times B minus A times C, and also B minus C times A equals B times A minus C times A. So there's a couple things that they are describing here with this grouping of things that seem very, very, very similar and redundant. So the takeaways from those examples are that distributive property works with addition and subtraction. So you can use either of them. And you can have the parentheses out in the front, or you can have them out in the back. So it doesn't matter what comes first, basically. Location of parentheses. Doesn't change the result. I don't really like that. What's that thing we just learned about? Let me flip back a couple pages to make sure I got it right, because that seems like it's here it is. The commutative property. So I'm going to cross that out and say commutative property. Okay. Let's look at some examples then. Our section starts out with a word problem because you guys are already getting pretty good at simplifying things. And they want us to practice, after the word problem, they want us to be practicing without variables first, just so that we can see how true it is. So they have a suggestion for you that is pretty interesting. You can use the distributive property to make multiplication easier. Now, I'm just going to do one example of this, and then if this is something that you're interested in, and want to look at and see more of, if you could reach out to me, that would be cool. I think that you guys all have a good handle on like long multiplication. So if you were given 7 times 49 and you didn't have a calculator, it wouldn't really make sense for you to try to use the distributive property to solve this. You would just do 49 times 7, and then you would end up with whatever your answer is, okay? If you are not as good at that and keeping track, we can use the distributive property and say that, okay, these things can go both directions. So if I have BA plus CA, I can turn that into B plus C times A. I'm going to say, all right, this is 7 times 49. What if I rewrite that as 7 times 50 minus 1? And you might be thinking, what? Why would you do that? Well, 7 times 50 is a lot nicer than 7 times 49. And 7 times 1 is also pretty easy. So I do the distributive property like that, and I would be getting that it equals 350 minus 1 times 7, which is 7. Now I just need to do 350 minus 7, which is 343. And that's my answer. And I didn't have to really think too much at all about more complex multiplication. I just had to do some 5s and then 7 times 1, so not bad at all. This is nice that this is possible, but it is not necessarily the best option for you. So like I said, if you want to see more, you're like, wow, times tables are awful for me. Talk to me. And we can look at that more. All right. Usually what we're going to be doing is simplifying expressions. So theoretically, yes, we can use the distributive property to make things a little simpler like that. Maybe we'll have something like, back with our 2x plus 8 that we had in the beginning here. Whoa! Did you guys notice that I had a huge typo there? Yeah, that's an 8. That's an 8. 2x plus 8, I can use the distributive property to say, well, there is a 2 in both of these, like a factor of 2. I can divide 2x by 2, and I can divide 8 by 2. So I could take the 2 out, and what I would have left over would be x plus 4. So this is a valid move. But we are not going to be using that nearly as much as we're going to be simplifying things, because it is a huge, huge deal when it comes to simplifying. So let's look at example 3. Oh, sorry. Forgot I wasn't doing numbers. Just example. This is going to be about simplifying algebraic expressions. So let's say we have 7 times 3w minus 5. Cool, we want to simplify this. We go through PEMDAS, and this is what we end up with. can't go any further without the distributive property. So I'm going to use a different color actually to, oh my gosh. Okay, go like this. I'm going to multiply the 7 by both of those. This is something that gets kind of interesting. So 7 times 3w minus 7 times 5. That's going to turn into 21w minus 35. That'd be my answer. What if I had 2 minus 5q times negative 3? Well, it's going to be the same process. This negative 3 is the thing that doesn't have an operation, so I multiply that by the 2 and by the 5q. Here's where it can be a little interesting because negative 3 times 2, that gives me negative 6. And then I'm going to say minus negative 3 times 5q. Because I've got these double negatives here, that's going to actually turn into a plus. The other way that you can think about this is you can say, okay, well that's a minus 5, so it's like a negative 5, and it's a negative 3. So a negative times a negative gives me a positive. So our final answer would be negative 6 plus 15q. Okay? I'm going to turn my page and let's do a try problem, okay? Try problem. Go ahead and do 8 plus 4n times 2. Pause the video. Good luck. Okay, you should have gotten 16 plus 8n for your answer. Remember, you can't just give me this right now. You might be thinking, okay, well, Miss Gibbons, it's really easy to do in my head. It doesn't matter to me right now, especially on the try problems, because I'm literally giving you this. I want to know that you actually did it in your head instead of writing it down. All right. Now, can this work for things that are maybe a little more complicated? So like 6v squared plus v minus 3 in parentheses times 4. Well, that seems a little crazy, but actually we can use it. So we are going to multiply the 4 by the minus 3 by the v and by the 6v squared. When we do that to all of them, then we are going to get 4 times 6v squared plus 4 times v minus 4 times 3, basically, which gives me 24v squared plus 4v minus 12. That would actually be my final answer. There's no way that I can simplify these anymore because I have v squared and v, and those are not compatible. They are not able to be combined. This step right here, where I just write out how I'm multiplying by 4, this is something that you will eventually not need to do, and I am comfortable with after you take these notes, you starting to maybe phase out of this. You don't have to do that. You could just say 4 times 6v squared and say that's 24b squared. I just want to show you this because it's a good thing to start looking at, and it's also something that if you're like, I need to show my work, how am I going to show my work here? You can always do that. It will not be like as required as other work showing. I also really recommend the arcs, so you don't miss any of your pieces, basically. But that is also technically more optional. Let's do another try problem and then see where we get with that. I think that'll be kind of the end for now. Let's do -6 times r plus 3g minus t. Oof, this one looks tough. You can do it though. Give it a try. And your final answer should be -6r minus 18g plus 6t. And that plus right there, that's going to be something that's going to trick a lot of people, because remember, I've got my negative and then I'm going to have a double negative because I have that minus t and -6. That's going to turn into positive, so I'm going to have addition there. That is your answer for that one. I'm going to stop at this point. We're going to have one more really pretty small example, and we'll call it good. All right.